Welcome to Afro Think Tank University. Today's lesson is about to begin, so get ready to learn something new. Let's dive in. Welcome back to Afro Think Tank University, Science section. Today, Amari and Zuri are entering one of the most advanced frontiers in modern science, the human brain. Before watching today's video, they'll use observation, logic, and curiosity to predict how tiny pieces of technology might communicate with billions of neurons inside our minds. Dialogue. Amari, take a look at today's lesson. Scientists have developed tiny brain probes that can communicate with the human brain. That almost sounds like science fiction. Zuri, it really does. But if scientists actually built something that small, it must have an incredible purpose. Why would they want to put tiny probes into someone's brain? Amari, my first guess is that they aren't trying to change the brain, they're trying to understand it. The brain sends electrical signals every second. Maybe those probes can listen to those signals. Zuri, kind of like putting thousands of tiny microphones inside the brain, except instead of listening to sound, they're listening to electrical activity. Amari, exactly. Every time you move your hand, remember a face, solve a math problem, or even speak, billions of neurons are communicating with one another. Imagine being able to study those signals in real time. Zuri, that could completely change medicine. If scientists understand how healthy brain signals work, maybe they can also understand what happens when something goes wrong. Amari, that's what I'm wondering. Could this technology help someone who's paralyzed? Could it allow a person to control a computer or even a robotic arm just by thinking? Zuri, and another question. These probes must be unbelievably tiny. How do doctors place something that small into the brain without damaging it? Amari, that's a great question. Maybe the video will show us how scientists solve that problem. Zuri, then let's pay close attention. The human brain is one of the most complex things in the universe, and today we're about to learn how science is beginning to unlock its secrets. Amari and Zuri continue asking questions, realizing that every breakthrough in science begins with curiosity. Before learning the answers, they challenge themselves to think like neuroscientists and engineers. Their goal isn't to guess correctly, it's to ask better questions. Dialogue. Amari, the more I think about it, the more incredible this sounds. The human brain contains billions of neurons, and every one of them communicates using tiny electrical signals. How can a probe that's thinner than a human hair detect something that small? Zuri, and not only detect it, but understand it. Imagine trying to listen to one conversation inside a stadium full of people talking at the same time. The brain must be even more complicated than that. Amari, exactly. Scientists must have developed incredibly sensitive technology. Maybe these probes don't read thoughts directly, they read the electrical patterns that neurons produce. Zuri, that would explain why computers need artificial intelligence and advanced software to interpret all that information. The probe gathers the signals, and the computer helps scientists make sense of them. Amari, here's another question. If these probes can read signals, could they also send signals back into the brain? Could they help repair damaged pathways after an injury? Zuri, imagine someone who lost the ability to move their hand because of a spinal cord injury. If scientists understand the brain's signals well enough, maybe they could help that person control a robotic arm or even regain movement one day. Amari, that could change millions of lives around the world. People with paralysis, neurological disorders, or diseases that affect communication might have opportunities that didn't exist before. Zuri, today's lesson isn't just about technology. It's about using science to restore independence, improve lives, and give people hope. Amari, I can't wait to see how these tiny probes actually work. Let's watch the video and discover how engineers and neuroscientists are turning what once seemed impossible into reality. Zuri, let's do it. Science has a way of making today's imagination become tomorrow's invention.
Have you seen neurons fire? You want to see? Hi, I'm Nuri, your friendly neighborhood science bestie. Today we're doing something called microelectrode array. It's a way we can watch neurons actually fire. The magic happens with this special chip. This is a microelectrode array chip. Today we're going to use this to look at nerve cells firing in models of the spinal cord.
Like I said, this is a microelectrode array chip, and in the center is like this gold grid, and it has little probes sticking out of it. And this is where our spinal cord organoid is going to sit. If you really want to know what a spinal cord organoid is, you're going to have to go watch my videos on them. But basically, we can take skin cells from patients and reprogram them to be like little mini balls of cells that have all the cells that you would see in the spinal cord. And right now I'm just cleaning this chip and preparing it to have our spinal cord organoids sit on it. So I wash it with water, I wash it with alcohol, and now I'm washing it with the food that the spinal cord organoids need in order to survive while we're measuring their electric activity. Okay, I put this chip under a microscope so you can see those probes kind of sticking out. If you look in that top right corner, you can see that the chip is a little bit scratched. This is a very delicate chip. It costs thousands of dollars because, like I said, it is gold. And we want to take care of it, make sure it doesn't have any scratches, because once it's scratched, actually that region cannot be recorded from. And I'm zooming in a little bit more so you can see these micro scratches. And once it get kind of tattered, we can't use it as much. But I just wanted you to see what it looks like. Each of these probes, we can look at electrical activity. So I'm doing a little bit more cleaning of the chip, and now I am putting the spinal cord organoid right on that chip. You can see, I just zoomed in for you. That is a tiny spinal cord organoid. I'm gonna measure 2, so I put another one there. And now I'm just using a little chem wipe to push them into place so that I can do my recordings. And you can see me very proudly showing you that they're nicely sitting on the chip. Now I'm gonna put this apparatus on top of them to kind of push the organoids down and make sure they're in good contact with the chip so we can get good recordings. Just making sure everything is properly in place. And now I'm putting that food or that media on the chip so that they will live while I do these recordings. And this is a little camera. So I'm gonna actually take a picture of their positioning and it'll make sense why in just a moment. But this is how they look really close up. So I take a picture of this and I do that so that I can overlay it with the recording. So this is how it looks when I'm recording. And this is kind of the plots that it gives me. And this is called a raster plot. In the bottom left corner, you can see the organoids and the neurons in them actually firing. This one is not that active, so I want to show you another one. This is another one I set up like I did before. And you can see that left one is firing like crazy. Those are the neurons firing in that organoid. And it's so cool. It's kind of like mesmerizing to see all the electrical activity. Microelectrode array is helpful for us to be able to look at the electrical activity of neurons firing, and it lets us ask questions about different diseases. So I study ALS, so it lets me know if in ALS they're more active or less active compared to healthy individuals. So it's a really cool method. Anyways, I just wanted to show you this cool experiment. I hope you enjoyed. This is what my raster plot looks like. I will see you next time.
The video answered many of the questions Amari and Zuri had before class. They discovered that the tiny brain probes are even more advanced than they imagined. Now they're comparing what they predicted with what scientists are actually accomplishing in laboratories today. Dialogue. Amari, wow, I didn't realize those brain probes were actually thinner than a human hair. That's unbelievable. Zuri, me neither. And the video showed that they're sensitive enough to detect the tiny electrical signals coming from individual neurons. That's incredible engineering. Amari, I also learned that doctors don't place them by hand. They use extremely precise robotic systems so the probes can be inserted accurately while avoiding damage to the brain. Zuri, that answered one of our biggest questions before the video. I kept wondering how something so tiny could be placed with that much precision. Amari, another thing that surprised me was how many neurons scientists can record at the same time. They're collecting enormous amounts of information to better understand how the brain communicates. Zuri, and all of that information can help scientists learn how movement, memory, speech, and even decision-making happen inside the brain. Amari, the part I liked the most was learning that this research isn't just for science, it's for helping people. Zuri, exactly. Scientists hope these brain-computer interfaces can help people living with paralysis, neurological injuries, and other conditions regain abilities they may have lost. Amari, it's amazing to think that something almost invisible to the human eye could one day change millions of lives. As their discussion comes to an end, Amari and Zuri begin thinking beyond today's discovery. They realize that brain-computer interfaces aren't just changing science, they're shaping the future of medicine, engineering, and humanity itself. Like every powerful invention, the greatest breakthroughs must be guided by wisdom, responsibility, and compassion. Dialogue. Amari, today's lesson showed me that science isn't just about making amazing inventions. It's about solving real problems that affect real people. Zuri, I agree. Imagine someone who can't speak because of a neurological disease being able to communicate again. Or someone with paralysis, controlling a robotic arm just by thinking. That's life-changing. Amari, the technology is powerful, but it also comes with responsibility. Scientists have to make sure these inventions are used to help people, protect their privacy, and improve lives. Zuri, that's one of the biggest lessons in science. Just because we can build something doesn't mean we should stop asking how it should be used. Ethics should grow alongside technology. Amari and I noticed something else. This breakthrough didn't come from one field of science alone. It took neuroscientists, engineers, roboticists, computer scientists, doctors, and many other experts working together. Zuri, that reminds us that the future belongs to people who know how to work together. The biggest problems in the world usually require many different kinds of knowledge. Amari, who knows? Maybe one day someone watching Afro Think Tank University will design the next generation of brain-computer technology, Zuri, or discover a completely new way to help people heal, communicate, and live better lives. Amari, that's why we never stop asking questions. Zuri, because every great discovery starts with one curious mind. Closing narration. Narrator, the future isn't something we wait for, it's something we build. Every question you ask today has the potential to become tomorrow's breakthrough. Stay curious, keep learning, and remember, learn something, teach something. Thanks for learning with Afro Think Tank University. Keep thinking, keep asking questions, and we'll see you in the next lesson.